Hi, my name is Jessica Budai, and I will be going into detail today about cell process capacity improvement. To start off, as discussed in one of our teaching notes specific to Module 5, we reviewed the theory of constraints. We understood it as a methodology for identifying the most important limiting factor that stands in the way of achieving a goal, and then systematically improving that constraint until it no longer is the limiting factor. Constraints are a common occurrence in all industries, and especially within the manufacturing industry. Identifying constraints can be used to understand where there might be gaps in a process which assist in the improving of the product flow. All manufacturing companies rely on material throughput in order to maintain a strong business. In this presentation, I'll specifically dive into 3 critical tools utilized in order to best understand a process performance in the machining of product. Therefore, I'll focus on this theory of constraints, value stream map, and then financial metrics applicable to operations specifically. The specific areas of the theory of constraints that I found most impactful are understanding your bottlenecks, identifying your longest lead time item, and improving throughput in order to meet demand. Bottlenecks are a very important metric for manufacturing facilities as they directly impact the amount of material that can be made through process of production. A bottleneck is identified as an area in a process which can't complete a process step as quickly as the step before and after it. It is important to review what specific products are going to be analyzed in the process in order to ensure the data gathered is consistent with the results being sought after. For example, if a process of a 60-foot pipe is being reviewed and this data is then compared to a process of a 2-foot pipe, the data will not relate to each other, which can lead to potential process changes that may additionally lead to added bottlenecks. Lastly, identifying process throughput is a critical metric manufacturing sites measure. Process throughput helps to identify what the available capacity is within the process in order to understand if a process can meet the customer demand. This setup, however, does not include spike orders and is designed around an analysis of historical and forecasted average demands. This leads us next to the value stream mapping. The value stream mapping details, which I'm going to specifically focus on, are understanding all of the steps within a process, identifying the value add versus non-value add steps, and then identifying areas of improvement. Typically, when a map is completed, the number of steps and decision points are captured and analyzed. The analysis of this can help identify which steps are value add to the process and which aren't. It is critical to understand what these steps are and whether they're value add or not, in focus pertaining to the customer. Typically, we ask ourselves, is the customer willing to pay for that? If the answer is no, then that most likely is a non-value add step. It is also important to understand the decision points in a process. In an optimal future state process, as we learn in our class notes, we don't want any decision points. If there are decision points in a process, that opens the door to potential errors being made. Combining both of these points leads us to understanding where our areas of improvement are. It allows us to identify the gaps in the process and the non-value added steps and potentially identify additional areas where we can fix these steps and improve our process overall. This leads us to our financial metrics. The financial metrics specific to cell capacity and flow are productivity and revenue per square foot. Productivity specifically is a critical metric as it is the number of units output versus the number of units input to a process. The more output you have versus the amount of input you have is directly your productivity. For example, if a company is to machine 3 pipes per shift and due to some cell realignment and additional process improvements, you're now able to produce 10 pieces per shift, then your increased productivity is 7 pieces per shift. Obviously, any manufacturing wants to help improve their productivity in order to make it the absolute highest as possible. The second critical metric is revenue per square foot. Revenue per square foot is the amount of revenue generated in a business divided by the square foot of that business. This is directly correlated to productivity because as you can produce more parts on a smaller square footage, then corresponding, your revenue per square foot increases similarly. Companies are obviously constantly striving to figure out changes they can do in order to improve their revenue per square foot. Overall, in order to maintain continuous improvement across a cell, you need to review all of the points I just made and go into detail about the notes we saw in class in order to continue analyzing your company and making it the best it can be. Overall, understanding where you are, understanding your bottleneck, and understanding how to optimize flow is critical to any process in making sure a company remains profitable.